In this video, we are going to be doing number 10 in chapter 4 of the AP Physics textbook on page 102. To start an avalanche on a mountain slope, an artillery shell is fired with an initial velocity of 300 meters per second at 55 degrees above the horizontal. It explodes on the mountainside 42 seconds after firing. What are the x and y coordinates of the shell where it explodes relative to its firing point? We'll start by visualizing the problem. So that's our artillery shell, launched at an angle of 55 degrees at an initial speed of 300 meters per second. So its trajectory will look something like that. Let's say our mountain is right here. So we want to figure out the x and y components of this point. And we know that it's in the air for 42 seconds. Now normally what we want to do when it is a projectile launched at an angle, we want to just start out by finding the x and y components of its velocity. This will be the x component. If you plug that into your calculator, you will get 172.07 meters per second. The y component will be this. So we have the initial speed in the x and y directions, and we know how long it's in the air for, and we want to find xf and yf. xf will be really easy. We can use our 9th grade equation, v equals d over t, where d, we'll just replace that with x. So x will be speed times time. So that will be 172.07 times 42. The reason we can do this is because it does not accelerate in the horizontal direction. So this is our x coordinate. Now it does accelerate in the y direction, so we'll have to use one of our kinematics. We are looking for yf. We have the initial speed, we have our time, and we're going to say our initial position is 0 on the ground. So it looks like we want to use our second kinematic. Don't forget to specify that it's the y component. So that term will go away because it's 0. We want to plug in 245.75 here times 42. And of course the acceleration in the y direction is negative 9.8. And if you plug that all into your calculator, you will get that number. So that is our y coordinate, and we are done with this problem.